We'll talk through what it means to be a function and how you can identify a function. So a function is just a special relation where the x values don't repeat. So when you're looking at a set of data, if you're just trying to identify whether or not the data represents a function, you're just simply looking for repeating x values. So there are two ways to test whether or not a relation is a function. By analyzing the given ordered pairs for the repeating x's, and then the second method is from a graph. But let's talk about the repeating x's in ordered pairs first. So when I analyze ordered pairs, I'm just simply looking at the x-coordinate. And remember the ordered pair, x comes first. So I'm just looking at the domain members, the x members. So I've got 5, 3, 2, 0, and -1. I have no repeating x's, so I would say that yes, number 1 does represent a function. When I look at number 2, I've got -2, 0, 2, 3, and 2. I see that 2 repeats. 2 occurs the first time with -4, 2 occurs again with +4. So I would say that the data represented in number 2 is not a function because of the repeating x values. Repeating y values are okay, but repeating x values are not okay. Let's look at number 3 together. Just looking at the x coordinates, the first coordinate, -4, -3, -2, -1, and -3. So I see here that -3 has occurred twice. The first time I see -3, the y coordinate partner is -1. The second time I see -3, it's paired with +2. So the fact that -3 repeats with different y value partners means this is not a function. And the other data is just arranged in a different manner. So let's move down and look at some other problems on the page. So here I've got the table display as well as the mapping. And it's easy enough to see, scanning quickly. Let's look at number 8 on the video. I'm just looking at my domain members, my x values, and I've got 1, 4, -7, 4, and -1. And it's easy to see that 4 repeats in the x column. 4 repeats with different y values, so I would say this is not a function. The mapping is a really easy display to see. So let's compare number 9 to number 10. When I look at the x values in my mapping, I can see that I have 4 different x values, and each x value just has one arrow indicating that it has a y partner in the other oval, in the other mapping column. So that means that this would be a function. Compared to number 10, look at -1. -1 has 2 arrows stemming from it, which means that -1, the first time -1 occurs, it occurs with the point 0. That's one ordered pair. The second time -1 occurs, it occurs with +7. So that means that I have repeating x values. X repeats. So number 10 is not a function. Number 9 is a function because I don't have any x values with 2 arrows leaving from the same x value. Each x value is just simply has one arrow indicating it has one y partner. Versus number 10, where -1 has 2 arrows stemming from it, connecting it with 2 different y values. So that's the difference. Whenever you're looking at just a set of ordered pairs, if the x repeats, the ordered pairs do not represent a function. The second way to recognize a function is by looking at the graph. So I'm going to go back up to the top for just a minute. When you're given a graph, there's something called the vertical line test, and sometimes I'll just use the initials VLT for vertical line test. And I want to visually show you how to determine when you're looking at a graph. I would like to show you how to determine using the vertical line test whether or not the graph represents a function. So let's do that. So first up, I have this discrete graph, meaning it's just comprised of points that have not been connected. But if I have 2 points that can connect up to make the vertical line, so this illustration is going to show you how to use the vertical line test. If I have a pair of points that can be connected to create a vertical line, then this is not a function. So number 11 is not a function. And then to tie it into what we just did, if I list the ordered pairs associated with the points, I see that I have +1 and +2 and +1 and -1, which means that the x value +1 has repeated. And when I plot repeated x values with different y coordinates, I plot 2 points that can be connected to make a vertical line. So that's how the vertical line test ties into the repeating x values. Let's look at number 13 on the video. And when I'm analyzing the points, this is another discrete graph, meaning it's just plotted points that have not been connected. I see that I have a pair of points right here, and that would be, let's see, I've got 3, 0, and I have the point 3, 3. So I've got the repeating x values, and then visually I could connect those 2 points with a vertical line, so I would conclude that this is also not a function. Now let's look at a continuous graph. So down here, number 14, this is a continuous graph because I have connected lines or connected curve. If I can intersect this graph in more than one spot at a time with my vertical line, then it is not a function. So here I'm drawing a few vertical lines through, and I'm intersecting this graph in 2 places all across. So this would not be a function because I'm able to use a vertical line to intersect the graph more than once. Looking at number 15, when I draw vertical lines, I only intersect the line once, so I would say that yes, that does represent a function. And then looking at the curve in number 16, and all of the 14, 15, and 16, they're all continuous because they're not just plotted points, they're continuous curves or lines. If I were to draw vertical lines in number 16, I don't intersect the graph, I don't intersect it more than once, so I would conclude that this is a function. And that's how the vertical line test works.